Hey, welcome everyone. I hope you're having a great day so far. Today we're going to talk about simplifying expressions, radical expressions that have square roots or perfect roots. Recall that n squared means multiply n by itself. So for example, this first one that I have, 3 squared is 3 times 3. And we know 3 times 3 is equal to 9. Looking at the next example, right, we have -8 times -8. So that's positive 64. But now if I have -8 squared, that's really -8 times 8. The only thing that's being squared is the 8. So that's why we get -64 here. Let's talk about square roots. If we see a radical like we have right here in this example, I have that radical with my a underneath it. So I have the square root of a is equal to b if b squared is equal to a. So in other words, if I have the square root of 25 is equal to 5, that's because 5 squared is equal to 25. So now you have your principal root. Your principal root is when you have the positive that's in front of the radical. The negative is when you have a negative in front of the radical. The cubed root, same thing with the cubed root. All right, so let's kind of look at a cubed root. We're going to talk about a lot of cube roots today, but 2 times 2 times 2. So 8 is a perfect cube. So the cubed root of 8 is then equal to 2 because 2 to the third is equal to 8. All right, so you've already heard me say it. It is called our radical. If you don't have an index, so our index is here, but notice that up here, right in this example, I don't have an index there. I don't have an index there because we assume that it's 2, the square root. The domain of a function is when you plug in some number and you get a real number back. All right, but we're going to be more specifically talking about perfect ones today. So since we're going to be talking about perfect ones today, I'm going to go ahead and I'm going to make a little chart that I will refer to a lot of times going through this section. Now, in your homework, you have a couple different videos that you're looking at because they're great explanations and hearing it in other ways about perfect squares and how to reduce radicals and things like that. I kind of have my own vocabulary sometimes. All right, but first thing I'm going to do is I'm going to make a little table of perfects. So in other words, my numbers. My numbers are 1, 2, 3, 4, 5, 6, 7, 8, and of course they keep going. Now I'm going to do my numbers squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, and 64. And of course they keep going. Now I'm going to do my perfect cubes, n to the third. 1 cubed is 1. 2 cubed, we talked about, is 8. 3 cubed, so you can always kind of take a minute and do this in your calculator. 3 times 3 times 3, 27. 4 times 4 times 4. So you see what we're looking at here. These are our perfect. So 27, this is 64. Here we have 225. And then 6 times 36, 216, 7 times 49, 343, and then 8. You can also do 8. 8 cubed, or 8 times 64, or 8 times 8 times 8. So I get 512. So then n to the 4th, 1, 16, 81, 4th, 5, 4th, 6, 4th. All right, so I'm going to go ahead and I'm going to do this for, n to the 5th and also n to the 6th. So you didn't need to, have me watch me plug this stuff into my calculator and write these down. But I just went ahead and wrote some of these down just so that you get an idea of perfects, whether it's perfect squares, perfect cubes, perfect fourths, perfect fifths, or perfect sixths. You can see one of the things I do want you to realize is a 1 is a perfect everything. All right, so now let's look at some of these first ones that we have right here. So it says find the square roots. So the square root of 9, the square root of 9 is 3. Now with this one is actually asking us for our principal root. The reason why it's asking us for the principal root is because there's no sign out in front. If there's no sign out in front, what do we know it is? It's positive. So same thing for B. B is then asking us for the square root of 25, which is 5. Right now, I can go right here and look at, we're just talking about ones that are perfects today. Now for C, I have a negative out in front. So since I have a negative out in front, I want a negative, then square root of 49, which is 7. All right, D, looking at D, I have the square root of 1 divided by 36. Well, you can really look at that and say it's the square root of 1 divided by the square root of 36. So I get 1 divided by 6. Now let's look at E. E says what times itself 2 times is going to give me a negative 4. Well, if I have 2 times 2, right, that's positive 4. If I have negative 2 times negative 2, that's still a positive 4. So when we see something like that, now let's even see what our calculator says too. So looking at our Desmos calculator, I'm going to take the square root of negative 4. When I look at the square root of negative 4, it says it's undefined. That's because it's not a real number. So we might just go ahead and say, I'm going to go ahead and say it's not a real number. Also, sometimes what do we write in the homework? We write does not exist. So what I'm going to go ahead here and write is that these can only be positive. That's all. They can only be positive. Now let's go and look at other examples here. All right, so examples of finding perfect cubes. So the cubed root of 8. We've already kind of done that one. So the cubed root of 8 is 2. The cubed root of 1 divided by 125. Well, look here. So I know the cubed root of 1 is 1. The cubed root of 125. So I'm going to look. I'm going to put 225. Put that wrong. So that should be 125, not 225. Sorry about that. That's actually 15 squared. All right. So here, what I can do here is I can look at my perfect cubes. These numbers right here are my perfect cubes. So 1, 8, 27, 64, 125, 216, 343, 512, and of course they keep going. okay? So I look here, I see 125. That root is then 5. That's how I use this. So my root is then, my denominator here would be 5. All right, so now the cubed root of 27. The cubed root of 27. So I can look right here under my cubes. Here's my 27. So my cubed root is then 3. Here's 3. Now I have negative 64. Well, first of all, I'm going to look at my perfect cubes. I see 1, 8, 20, 27, 64. So 64 is a perfect cube, but now it's asking, can it be negative? Well, let's check. Negative 4 times negative 4 times negative 4. Well, if I have 3 negatives, it's going to be a negative, and I'm going to get negative 64. So therefore, my cubed root is negative 4. So in this case, I can have a negative underneath there. Now let's even check and see what our calculator says. So here, I'm going to go ahead and plug that in. 3, and then underneath my radical, negative 64. When I press enter, I get negative 4. So that is in the domain. All right, now here's some other numbers, right? The cubed root, or excuse me, the 4th root of 16. I can once again go on here, looking at my perfect fourths. 1, 16, here's my 16. My 4th root is then 2. So my answer here, 2. Then looking at my 5th root of 1. 1, remember, is a perfect everything, so that's just 1. The 5th root of negative 1. Well, the 5th root of negative 1, we didn't write it here. Remember, our cubes can be positive or negative. Our fourths, just so you know, can only be positive. And let's test with our 5th root. 5th root of negative 1 is going to be negative 1. The 6th root of negative 1, it doesn't work. So we can have positive and negative for odds, but when they're even index, it only can be an even number and be a real number. That's what we call it. So here, I'm going to get negative 1. And for my example D, I'm going to write does not exist. All right, so now we're going to be looking at our Now we're going to be looking at our perfects that are variables. All right, so there's a little bit extra that's on here, but I'm gonna go ahead and I'm gonna show you what your directions say in your homework and how it's a little different than what you might see that I do here. All right, so once again, all of these are going to be perfects. So let's talk about what our perfects as our variables really look like. So I'm going to go back to this little table that I did, and now I'm going to do my variable. So I'm going to start off with just my variable of just x. So my variable of x, right? So I have x to the second, x to the third, x to the fourth, x to the fifth, x to the sixth, x to the seventh, and so on. Right, so you know that they keep on going, just kind of like our numbers keep on going. But now we're going to talk about my variables squared. So now let's say I go back and I'm going to square that x. So of course I'm going to get x squared. So then again, I'm going to square my next one. Well, when I square my next one, I actually get x to the fourth. squaring my next one, writing it squared, I have x to the third times 2, right? Because I'm multiplying my exponents, so I actually get x to the 6th. So do you see that pattern that's happening? What's that pattern that's happening? X to the 8th, x to the 10th, x to the 12th, x to the 14th. So what do you notice about all these perfect squares? 2, 4, 6, 8, 10, 12, 14. Yeah, they're all even. Okay, they're all divisible by 2. They're all multiples of 2. All right, let's talk about our variables cubed. So now I'm going to go back up to the top, right? And now I'm going to start cubing them. So I have x cubed. Then my next one, what's my next one going to be? X to the 6th. All right, now x to the third raised to the 3rd power. X to the 9th. Okay, now look at my pattern. So what's my next one going to be? X to the 12th, x to the 15th, x to the 18th, x to the 21. All of my exponents are multiples of 3, or you can say all my exponents are divisible by 3. So my variables to the 4th, x to the 4th, then x squared to the 4th, x squared to the 4th is going to be x to the 8th, then x to the 12th, x to the 16th, x to the 20th, my variables to the 5th, x to the 5th, x to the 10th, x to the 15th, x to the 20th, my variables to the raised to the 6th power, x to the 6th, x to the 12th, x to the 18th, and so we see that pattern that keeps going. All right, so there is a little bit of extra here with this definition that says if you have your index is even and your exponent underneath is even, you need to take the absolute value. So for example, like looking at this first one, what's my index that's not written there? My index that's not written there is 2. So is 2 even? Yes. Is x squared? Is that even? Yes. So when I would actually write this, I would write that as the absolute value of x. You're not going to be doing that in your homework. You're just going to be writing x. And I'm going to show you why. So, but notice that they're perfects. So here, once again, I have the square root, right, of b to the 4th. So the square root of b to the 4th. So I'm going to go back over here for a second. And here are my variables squared. And I'm looking for the 4th, right? So that root is then 2. What else can you say that you're doing here? Yeah, you're just dividing. 4 divided by 2 is going to be 2. So now because this is even, I had even, even, I don't have to have that absolute value. I only have to use that absolute value if I have even, and then I would have to, and this was an odd. So I'll even go ahead and write that on here. Even, and then this is odd. Then you would have to say absolute value. You would have to say absolute value because you need to make sure it's the absolute value because you have the 2 even values. All right, looking at number 3, the cubed root of y to the 3rd. What's my cubed root of y to the 3rd? Yep, just y. Now, because none of those are even, I don't even need absolute value. Looking at number 4, I'm taking the square root of a to the 8th. Well, that's going to be a to the 4th. I'm looking for the 8th root of m to the 8th. That's gonna just be M. It should really be the absolute value of M, but in your homework, you're just gonna write M. So let's look at why you're just gonna be writing just M. So if I click on here, as an example, like let's look here. All right, looking at here, I have the square root of 9w squared. It says assume all variables represent positive values. So because it says assume all variables represent positive values, you don't need that absolute value. It's telling you not to worry about it. So what's the square root of 9? 3. What's the square root of w? W. That's how you would do a question like that. So right here for one, like question 10, the cubed root of z to the 12th and h to the 18th. So if you're not sure, I'm going to go back here and look real quick here. So here I'm looking for the cubed root. So I'm going to look at my perfect cubes. So these right here are my perfect cubes. So I can see z to the 12th. So here's my 12th. So I know when I take the cube root, it's going to be z to the 4th. So z raised to the 4th. And then h raised to, looking on my chart, going over, I have 18. The cubed root of my 18th power is my 6th power. All right, so let's just go ahead and finish up our worksheet here. So the cubed root, the cubed root of y to the 12th is going to be y to the 4th. The fourth root of b to the 4th is going to be b. It's the absolute value of b, but we're just going to write b. The fourth root of n to the 20th, the fourth root of n to the 20th would be n to the 5th, which would be absolute value, which we're just going to write that as n to the 5th. So this would be absolute value, but we're going to go ahead and write that as, because it's going to say in your examples, right? It says for all of these questions, assume all variables represent positive values. So therefore you don't need your absolute values. I hope this helps, and I hope you have a great day. Good luck on your homework.